Welcome to qnawire.
In this problem, we have defined the angle theta that a block hanging from the ceiling of a car makes as it's going around a circle. Now, if we draw the free body diagram of the car, like I've done here, we can see that there's a tension force pulling the block up, as well as a gravitational force pointing down. I've moved the gravitational force up here. You're right if you're thinking that it should be pointing down from the block, but I've just moved it up here to make it clearer what the relationship is between the components of the tension force and the gravitational force. Now, as you can see, the y component, ty, let me adjust my pen, is what's canceling out the gravitational force mg. And that vertical component, ty, is equal to t cos theta, as you can see from the labeled angle in the diagram. Now we also have a horizontal component, and since something must be responsible for the centripetal force acting on the block, that must be what's equal to mv squared over r. Using the same logic and trigonometry, we can say that t sine theta is therefore equal to mv squared over r. Now we have two different equalities that have an angle value in them, so we can stack them on top of each other, divide them, to find a relationship with only one angle measurement. So we get t sine theta over t cos theta is mv squared over r over mg. Canceling out our m's, we find that the tangent of theta must then be equal to v squared over g r. Then, of course, theta is equal to the inverse tangent of that same value. Now we have everything in terms of quantities that we know, and that enables us to simply plug in. And we get 28 meters per second squared all over 9.8 meters per second squared times 150 meters. When we solve this, we find that theta is equal to 28.07 degrees, or to round to the nearest full angle, 28 degrees. And that is going to be our answer for this problem.